Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about ExcelR and I enrolled in ExcelR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they are also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, ExcelR.
Recently, I was searching for digital marketing courses online in Google, and I came across ExcelR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the ExcelR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, ExcelR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, ExcelR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for ExcelR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by ExcelR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with ExcelR's program, and by the end of the training program, I was able to develop my own application. And through the development also there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest ExcelR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is the students' doubts gets cleared and everything else. So today I came down to the ExcelR office to collect my certificate. So I got to know about what other courses ExcelR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens. And they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which ExcelR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend ExcelR to everyone who's listening to this, and also to all my friends, that I had a very good experience with ExcelR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about ExcelR program. I took part in the ExcelR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you ExcelR for giving me this opportunity, and I would also recommend all my friends to take part in the ExcelR programs. Thank you.
My name is Tasneem. I'm the senior manager at 98 Percentile in the HR department. And today we did a wonderful drive with ExcelR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at ExcelR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what ExcelR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident, and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and ExcelR in future. We are really looking forward to have many more drives like this.
my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at ExcelR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that, and that's what I felt. And I guess they have been taught pretty well at ExcelR, so that's how they have performed good in their aptitude and the technical tests. So I wish them very all the best, and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited ExcelR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of
Good evening, everyone. Am I audible? Just let me know. Okay. All right, let's start the session then. Okay, I guess more will be joining. Until then, let's recap what we had studied till now. Okay, so yesterday we were studying about cryptography. Okay, so we study what asymmetric cryptography is. Okay, where we need another's public key. We need another's public key to encrypt the message. Okay, and so that the other person can decrypt it using their private key. Okay, so this concept that both the keys belongs to a user who is a recipient, okay, solves that problem. because private key belongs to the user only, right? Then we got to know that asymmetric cryptography is not much enough because we have to protect users identity as well. For that, we have seen how digital signature worked, okay, where the message has to be signed, okay, where your identity or message has to be signed with your private key, because private key is the only thing on the internet that belongs to the user, okay. Now we have seen that cryptography, okay, and along with digital signature, okay, we are able to maintain the data's confidentiality and authentication, but now we have to maintain the integrity. So we have seen that hashing plays a role here to provide integrity. It matches, it always it always verify if the information is accurate or not, it's still reliable or not, okay. So this is something which is really important in blockchain, because blockchain relies on this reliability. Yeah, the data should be accurate every time. So this hashing plays an important role here. Okay. Now before starting, actually, to see how hashing is used in blockchain. Okay, let's understand what this block is. Okay, let's see what this block is. All right, I'll share my screen. I think my screen is visible to everyone. All right. Okay, before starting block, let's see how a token works. So I told you that token is just a representation of your digital signature or your private key. And I also told you this coin is nothing, it's just an entry. It's just an entry on the blockchain. And we are all agreeing to it. Suppose I have written it I have written 2 Bitcoin. 2 Bitcoin. So this 2 Bitcoin is just an entry. Is just an entry. So you can imagine it as a what file. In a what file I have written 2 Bitcoin. Suppose this right now belongs to Mantavya, or let's say Alice. So Alice will apply her this signature. I hope it's looking as a signature. Okay. Suppose this is a signature. Okay. So this signature proves that this 2 Bitcoin belongs to Alice. Okay. It's just you can imagine just a what file, and in the what file we have written 2 Bitcoin, and then the person has signed it, the owner has signed it. Just visualize it right now. Okay. Now suppose this Alice wants to transfer this coin to, let's say, Bob. So what will happen? This ownership will be transferred. So I'll draw a bigger box. Okay, and then in the smaller box. So in this smaller box, we have written 2 Bitcoin, and we have the old sign of Alice. And now there will be a sign of Bob as well. Okay, there will be a sign of Bob as well. Okay, now suppose Bob has intended to send this Bitcoin to, let's say, a third person, let's say Oscar. Okay, so again I'll draw 3, 1, 2, and 3. So inside it was Bitcoin BTC, Alice, and then Bob, and now Oscar. Okay, so you guys can see we are also maintaining the ownership. I mean, we are tracking the ownership. Suppose if someone wants to check before Oscar, who was the owner? Bob. Before Bob, who was the owner? Alice. Okay. So 2 Bitcoin or Bitcoin is just a number. It's just a digital entry. Okay. And that digital entry has to be signed by your private key, because you have to you have to show your ownership. Okay. So this thing, your private key, this is your private key. This is your private key, and it belongs to the user. Belongs to user. So that's why we say total ownership of the data. Total ownership of the data with user itself. Okay, so this private key is not in the hand of any other person. Because if it is in the hand of other person, they can use it, they can sell it, they can send it to anyone. Okay, even without the consent, okay, with of the original owner. All right. So this is exactly what a coin or a token is. Okay, so what's important here is that coin is just not a value. Coin is actually something that proves your ownership. Okay, I'm saying this again because when we'll go to application, when we'll see various application that works on blockchain. Okay, so apart from cryptocurrency, what's important is ownership. I told you the example of land ownership, the Karnataka government. So this ownership, a token is representing your ownership. Okay, I think it's clear now. All right. So if you want to take a screenshot, you guys can take it. I'll write it. Okay. Alice. Okay. This is Bob. This is Alice. This is Bob. This is Oscar sign. Okay. Take the screenshot. Cool. Now that we have seen that blocks are connected to each other. Okay. First, I'll draw a diagram. The same diagram. Okay. A peer-to-peer connection. Anybody left? Yeah, no one. Okay, so we have seen that blocks are connected. Okay, these are the blocks. These are the blocks. Now, guys, the users are represented with their computer, Okay, and the computer is known as node. Okay, suppose I'm talking about this person. This computer is using their computer. This is their laptop. So this laptop is known as node. Okay, so it's node that are connected to each other. This is the node. This is the node. Node are just computers, okay, that are running the blockchain software. Okay, so node, a blockchain node. What is a blockchain node? Blockchain node is just a user. It's just the computer who is running the blockchain software and participating in network. What is the participation? Told you that mathematical puzzle. So they are participating. Okay, that's why a node is just a user. It's just a computer that is running a blockchain software and participating in the network consensus and its security. So that is what a node is. Okay, so we have seen a node. We have seen a node. Okay, now suppose in the conventional system, suppose I want to send someone a parcel. So what I need their addresses, right? I need their addresses. So every user or every computer or every user, I'll say, will have their own address. Okay. So suppose if I want to send someone a parcel, so what I will need, I need their address, right? I'll need their address. Okay. Now if you guys can connect it, address, I need your address. I need your address. I need your address because I have to send you Bitcoin, or let's say any the cryptocurrency. I need your address. Guys, have you listened this before? I need your address. I'll give you a hint in cryptography, in asymmetric cryptography. If I want to send you a message, I need your public key. I need your public key to send you a message. Here what I'm saying, I need your address. I need your address. I need your address so that I can send you the Bitcoin. That means address. When we talk about this address is nothing, it's just your public key. Okay, so this will be having address. Suppose it's address 1, this is address 2, this is address 3, this is address 4, and this is address 5. So everybody will be having their own address, and address is nothing but just a representation of your public key. Okay, Suppose I want to send Bitcoin to someone, so I'll say, if I'm a technical guy, so I'll say, I'll give you a public key to me. But what people say, because blockchain is for everyone, it's not just for technical guys, okay? It's not for technical people. So they have named such thing which is, which is understandable everyone. So they have renamed public key to address, because address is something which we can all understand. What's the address? Address is something which somewhere lives, okay? So if I want to send someone Bitcoin, I'll need their address. I need their location. Okay, so location, address. So this is what public key is. Okay, so now you can see how things are working peer to peer, because it's actually a message. Transaction to Bitcoin is just a message. Okay, and I have to send it. I have to send it by needing someone's public key. Public key becomes an address. So it's directly creating a peer to peer network. Okay, so address is just a public key. Okay. Okay, so A2, A3, A2, A4 means A2, A5 means they are addresses. Okay, don't get confused here. All right, so we saw two concepts here: what is node and what is address. Okay, so address is just a hash of public key. More accurate, I have written it everywhere. I'll share my book. Okay, so address is just a hash of a public key, because I don't want, because public key is very large. It's very large. I'll show you. So when you hash it, it becomes small. Okay, so it's much efficient, and you are not directly giving a public key. Okay, it's a hashed version of it. Okay, okay, just take a screenshot. Don't worry, I have written it everywhere. I'll share my book. Okay, now let's understand what these blocks are. If I zoom into it, if I zoom into the block, what we'll get. Okay, if I zoom into these blocks, what we will be getting here. Okay, so this is now what we'll see. All right, now we'll see what actually inside the block. We have seen from the upper side, okay, on how exactly blockchain is, how it works, what are the transactions, okay, how it works. Okay, we'll see them in technical detail more. Okay, but now let's see what's inside the block. Okay, so I'm rubbing this. If you want to take a screenshot, take it. Take it. Okay. Okay, so now let's talk about a block. Now inside a block, we have two data structures. We have two more data structure, two more blocks, you can say. Okay, we have two more structure. One is known as block header. Another is known as block data. Block header is really important because it contains the metadata of everything. It contains everything which is related to block. Block data is something which actually holds the data. Okay, now if I zoom into more, if I zoom into this block again, if I zoom into this block again, what I see that there are some parameter. First parameter is index, or the numbering. Index means numbering. Index means numbering. At what number this block is. I told you the first block, the zeroth block is known as Genesis block, if you guys remember. The first block or the origin of the blockchain is known as Genesis block. Okay, if you guys remember. Okay, so first thing we have index, or the number of the block. Second thing we have previous hash. Third thing we have current hash. Fourth thing we have timestamp. Fifth thing we have, which is known as nonce. Okay. So what is index? Again, the numbering. Previous hash. Previous hash means it's the hash of the previous block. Okay, I'll tell you. Current hash means the hash of the current block. Timestamp. Timestamp means at what time the block is created. At what time the block is created. Okay, because blockchain it's dependent on time. Everything here is timestamp. Okay, everything here is timestamp. We have to mention time. Okay, and fifth thing is known as nonce. It's a proof. Nonce is just a proof. Okay, so I'll tell what nonce is. Now, if we look into this block data, if I zoom into it, okay, we have list of transactions stored in Merkle tree. So block data is the actual place where the transactions are stored. Okay, it's the actual place where the transactions are stored. T1, T2, T3, T4, blah 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 blah. Everything is stored here. Okay, just take a screenshot. Taken? Any doubt? Jed, yeah, it's really benefits for CS students because it's a technology, right? So like we have AI, we have cybersecurity, we have blockchain technology. Okay. Right now we are understanding concepts, we will be making a small project, not a project, but yeah, we will be see how smart contracts are created. A smart contract is just a code, okay, on a decentralized network. So it's beneficial for students, CS students. Merkle tree I'll discuss. Okay, if you are a CS student, okay, it will be really easy for you, but don't worry. Okay, it's just a tree. I'll show how it works. I'll explain. Just take the screenshot. Any doubt till now? Any doubt? Just let me know. I guess no doubt. All right. Because when I make you learn things, I'm not able to see the chats. Okay. Okay. Now suppose I'll draw the diagram first again. Why have I rubbed then? Draw. In the example, if you guys remember the classroom example, we have taken three activities. Okay, suppose we are taking again three activities only. Let's say three transactions T1, T2, T3. First, if you guys remember, they are stored in a memory place. Sorry, they are stored in a temporary place, which is just a RAM of your computer. So when a block is created, they are stored inside this block data. Okay, wait, I'll write everything here first. Okay, so we have index, we have previous hash. Okay, we have current hash. Fourth, we have timestamp. And fifth thing, we have nonce value. Okay, so this is the block data, block header. Now, suppose there are four transactions that happen in the blockchain network. Suppose T1, T2, T3, T4. Now they are stored in Merkle tree. Now, what is Merkle tree? Let's see it. So again, I'll show here. I'll show here. So Merkle tree is also known as a hash tree. It is known as a hash tree. It is efficient to check, to verify the transactions reliability, if they are changed or not, that we have seen the hash concept. So how it happens is, suppose this is T1, this is T2, this is T3, and this is T4. Okay. Now we will hash it. We'll hash every transaction. So suppose T1 hash is H1, T2 hash value is H2, T3 hash value is H3, and T4 hash value is H4. Okay, now they are combined in pair. They are combined in pair. So H1 and H2, they will be combined together, H1, H2. Similarly, they will be combined together. They will be, yeah, the H3, H4. Okay, now we get the last thing, which is again the amalgamation of every hash H1, H2, H3, H4. Okay, so this is what a Merkle tree looks like. It's a hash tree. It is also known as a hash tree. Okay, and the upper node, this upper bubble is known as Merkle root. As it's a hash, so we'll call it as a Merkle root hash. Merkle root hash, and this entire thing is a Merkle tree. Okay, it's used for verification. Okay, if someone tries to change the data in a transaction, this tree will break, because again hashing will verify with the old hash. Okay, so this is the Merkle tree. Now, what do you think, guys? This thing is H1, H2, H3, H4. What do you know? What do you think about it? I'll see the chat box. What do you think is H1, H2, H3, H4 is? It's a free course. It's a 15 days course. Okay. And I guess if you want to take a course, you have to discuss with the ExcelR management. Okay. What do you think, guys? This H1, H2, H3, H4 is? Anyone? What do you think this is? H1, H2, H3, H4. Header. What header? Yeah, it's a header. What do you mean by header here? The title. Jay, this is the 15 days course. Okay, it's a 15 days course. Okay, right now, so it's free. It's free for everyone. Everyone can see it. It's live on YouTube as well. It's a hash header. Hash header. Okay, but if you see the entire diagram of that block, what do you think this H1, H2, H3, H4 actually depicts? Size. No, not actually the size. Hash values of H are again given hash values based on maybe yeah, it's a parent node. Yeah, but what's its utility inside the block? Jay, we'll come to that in the last. Okay, we'll come to that in the last. Maybe a parent node. Yeah, it's a parent node, but what's its utility inside the blockchain? Inside the block, actually. Okay, I'll tell, no problem. So this is the thing L, but this is just your current hash. Okay, so this hash that we calculated inside the block header, its metadata will be stored inside the current hash. So this is nothing, just a current hash of the block. Okay, so this H1, H2, H3, H4 is just the current hash of the block. All right. Okay, if you guys want to take a screenshot, just take it. This is Merkle tree. All right. So this is nothing, just your current hash of the block. This is just the current hash of the block. Taken screenshot? All right. Now let's see how blocks are connected to each other. Very important thing. Oh, all right. Now, suppose I'm creating 3 blocks here. First block doesn't have a previous hash. Okay, it's the origin. Suppose this is the origin. It starts with number 0. Then we have a first block which will be having previous hash. And we have second block. Okay, so suppose we calculated the hash of this block. We have block header, right? And we have block data. Suppose current hash. Suppose current hash of this block is, let's say, H1, H2, H3, H4. Okay, if it's not visible, I'll write again. Instead, I'll just write H1, H2, H4. Yeah. Suppose the current hashes of the block is H1, H2, H3, H4. Okay. Suppose we calculated using the Merkle tree and it came out to be H1, H2, H3, H4. Okay. Now once this one block will be created, this will be having current hash as well. First it will be having previous hash and then we'll be having the current hash. So this previous hash is nothing, just the hash of the previous block. So it will be again H1, H2, H3, H4. Okay. Now this one block will be having its different transaction, new transaction. So again, let's say a new hash is calculated for this block. Suppose that the hash is H5, H6, H7, H8. Okay. Now once this two block is created after 10 minutes. Okay. After, I'll write it plus 10 minutes. Plus 10 minutes. I'm talking about Bitcoin right now. Okay. So it will be having its previous hash and it will be having its current hash. So this current hash is just the previous hash of the next block in the next block. So again it will be H5, H6, H7, H8. Suppose again we calculate the current hash of this block, it came out to be H9, H10, H11, H12. So this is how it will go on. Now guys, can you see, there's a line, there's something which are connecting the blocks. Okay, you guys can see that blocks are now connecting with each other, they are connected with each other. So this connection, this thread, this invisible thread is just the hash of the previous block. Okay, so if someone asks how blocks are connected, so blocks are connected in a manner where a block contains the hash of the previous block. Okay, so this is how the blocks are connected to each other, forming a immutable chain. Why immutable chain, guys? Because someone, let's say, tried to change a data inside a blockchain, the entire hash value will be get changed, right? The entire hash value will be get changed. Suppose in this block, someone tried to change the data. Oh, sorry, in this data, sorry, in this block. Okay, a bit of data is changed. A bit of data is changed. So the entire, we got a new hash. And suppose that new hash is H13, H14, H15, H16. Now, when this hash will be changed, what the next block is storing. So this will disconnect. Okay, and this block will be connected to this block, and this will be discarded. It's right now theoretically, okay, it's right now theoretically possible that you can connect this block with the uh, with the block which was the previous one. Okay, because right now there's no such cases where this hash was compromised in blockchain. Okay, so right now it's theoretical that the next block will be connected to the previous block, and the block where the data is being tampered, it will be discarded. Okay, so that's how immutable blockchain is. Because it stores the hash of the every block in the next block. Okay, so blocks are connected with a chain, and that chain is just a hash of the previous block. Okay, are you guys getting me? Let me make it much again much better way. Yeah. Okay. So this is how blocks are connected to each other. So now we have seen how blockchain, I mean the entire system of blockchain uses cryptography, asymmetric digital signature for transaction initiation and its creation, and hash for the for connecting the blocks with each other. If you guys remember the classroom example, the stapler. Okay, so you can imagine that stapler is a hash value now, connecting pages or connecting blocks with each other. Okay. No, Yusuf. See, address, it's not a address. It's a hash and public key are different, right? Public key and private key is used for the transaction, right? Transaction signing, message signing. Here, it is hash. It is a hash which are connecting to each other. So it's not the upcoming address of the next hash. Okay. It means, wait, I'll read it again. It means it contains the upcoming address of the next hash. Means it contains the upcoming address. No, Yusuf, no. Any other doubt, guys? Any other doubt, just let me know. It's strange you guys don't have question now today, or everything is clear. Just let me know. Okay. All right. Okay. Now I'll share a book that I have written. It's a playbook kind of thing. I'll share it with you guys as well. Just give me a minute. Right now I know it's everything is technical, but when we'll see the applications, okay, then it will be really interesting. We'll see how world are using it. So I guess I have my screen is visible. So this is the blockchain technology playbook I have created. So table of content, I'll share with you. I wanted to read it. Okay. So I have discussed history of money that I already discussed with you guys, but here I have written more. Okay. We have discussed what Bitcoin was, the Bible for blockchain technology, how it was known as a money for criminals initially. Okay. Then we understood what cryptography is. Okay, what peer-to-peer network is. Okay, have you guys ever used what do I say? Torrent network to download movie or any media using torrent? Anyone? I think we all did, right? So you know how exactly torrent works. You know how exactly torrent works. Uh, Use a table of content mean what I have written inside my book. What are the content you will read? Okay. Yes, I. Okay, in a peer-to-peer network, we can actually, I mean, the entire peer-to-peer network is connected using a peer-to-peer network. Funny Prasad, the size of the block, if you ask me for Bitcoins, it's right now 4 MB. Okay, it was initially in 2009, they started with 1 MB, but now it's 4 MB. Chat box, I guess I'm not allowed. Okay, I will share in the document that the team has sent me. Okay, I'll share it there. Sorry, when we end the lecture, right? So the team will help you. They will provide you with the link. Okay, and I think it's visible to you on LMS as well. All right. So now let's discuss what peer-to-peer network is. Again, if you guys don't know about it, see, suppose this is me. This is me who wants to download a movie. Who wants to download a movie? Oh, wait, my share screen is not shared. Yeah. Suppose this is me who wants to download a movie, but I want to download this movie from a centralized location, from a centralized database or a centralized platform. Okay. Okay. Suppose that movie is of 3 GB. Movie is of 3 GB. So the entire data belongs to centralized platform. Okay. So how am I, suppose this is the database. Okay, this is their database where the 3 GB movie data is stored. Now I will download this data from their server or their database. Okay. Now suppose this line represents internet. Okay, this line represents internet. Sorry, I have a sore throat today. Okay, so this line is the internet and we are downloading this movie. Okay, now suppose you downloaded 50% of the movie. You downloaded 50% of the movie. Okay, then what happened was there was an interruption in the internet. There was an interruption in the internet. Okay, your internet got disconnected. Your internet got disconnected when your movie was just downloaded 50%. Okay, so now what will happen? Your data will be corrupted. Your data will be corrupted and you have to download it again. Okay, it will be corrupted and you have to download it again. You have to download it again. Okay, so that's a problem with centralized platform. I think we all have faced this problem. Okay, when in the middle of, when we are downloading something in the middle of it, let's say internet is disrupted, so we have to download the entire thing again. Okay, now how this problem can be solved with a peer-to-peer network? Okay, this is what we'll see now, and this is what I'm talking about, peer torrent network. Okay, torrent network totally works on a peer-to-peer network. Suppose this is again me, the user who wants to download a movie of, let's say, again 3 GB, and it is available on a torrent network. It is available on a torrent network. So what this torrent network has done is, suppose we have 3 GB data, so there's an entire peer-to-peer network behind it. Suppose this is person A, this is person B, and this is person C. They are connected peer-to-peer. Okay, now everyone will be having 1 GB data each, because here the data is fragmented. Your movie will be fragmented into 3 parts: 1 GB, 1 GB, and 1 GB. 1 GB, 1 GB, and 1 GB. Now, as soon as you start to download it, as soon as you start to download it, suppose you downloaded 2 by 3rd part. Okay, you downloaded 1 GB plus 1 GB. And again, suppose there's a disruption in the internet, the remaining 1 GB is left. Okay, and the remaining 1 GB is left. Now, I don't know if you have realized it or not, guys, if you have used torrent or not. Suppose if I've downloaded 50% of the movie using torrent, I can still watch 50% of the movie. Have you seen that? Have you seen that before? Have you seen that? Suppose my movie is downloaded 50%, so I can watch the 50, I can watch the movie till it reaches to 50%. I can watch half movie. Okay? Because here the data is fragmented and it's available in a peer-to-peer network instead on a centralized system. Okay? So this is what a torrent network is. Again, suppose if the internet is back again, the remaining 1 GB will be downloaded and I'll get the 3 GB, which is the whole movie. Okay? So this is what a torrent network is. This is how torrent network works on this peer-to-peer network. Because here the data is available. It's available in a decentralized manner. If not from single place, you can take from another person. Okay? Now, everybody says that torrent is illegal. So what do you think, guys? Is torrent illegal or the activities that are happening on torrent are illegal? What do you think? Karthik, I'll send. Okay? Mohammed, it depends on the algorithm you are using for hash. If you are using SHA-256, it's of 256 byte length. MD5 much smaller, MD2 much smaller. Okay, so it depends on the size. Activity? Sorry, Pratna. Prarthana. Both the users and the developer. Wait a minute. What I asked, it just slipped from my mind. What I asked, can somebody just remind me? What did I ask you guys? Please reply. Did I ask something to you guys? Oh, right. Yes. So is torrent illegal or the activities? Yes, exactly. Users, developers. See, yeah, again, torrent is not illegal, but the activity that are happening on torrent are illegal. The reason, because suppose if you are a director of a movie, you put a lot of effort, you put all your hard work to create that movie, all the actors that were associated, all the crew members that were associated, they all did their hard work, okay, for that movie. Now, suppose if someone released that movie for free without their consent, that's a crime. If you read about the Copyright Act or the Copyright Act and the Trademark Act, or let's say the Patent Act. So it's a crime. You cannot sell something without the permission, without the consent of the owner, the author. That's why all the activities on torrent are illegal, because it's without the permission of the owner. Okay. So this torrent network uses this peer-to-peer network. Okay. So that's what I have written inside my book. If you guys open this peer-to-peer network, I'll read it for you because you are a lot of guys. So I'll read it for you. Imagine you are downloading a movie from torrent. If you have done this before, you might have noticed something interesting. You can still you can start watching parts of the movie even before the entire file is fully downloaded. Why is that? This happens because each part of the movie file is independent of the other. As soon as a segment is downloaded, you can watch that portion of the movie. This is a key feature of peer-to-peer networks. Now, think about downloading a movie from a centralized system, like a traditional website. In this case, the movie file isn't fragmented. You have to wait until the entire file is downloaded before you can start watching it. If there's any interruption or slow connection, you have to wait for the whole file to finish downloading. This is because the data is stored as a complete unit. It is stored as a complete unit on the server. Okay. Here's where the beauty of P2P networks comes in. In a peer-to-peer network, data is fragmented and distributed among multiple peers or the users. When you download a file using a peer-to-peer network like a torrent, you're not just downloading from a one source. Instead, you're downloading different parts of the file from multiple peers simultaneously. This makes it faster and more efficient. So we have seen a fragmented data 3 GB into 1 GB, 1 GB and 1 GB. Distributed system, peer-to-peer network. Instead of relying on a single central server, each peer contributes to the downloading and uploading process. Resilience and speed. If one peer goes offline, you can still download the needed part from the others. This decentralization makes the network more resilient and often faster. So this is how peer-to-peer network looks like, and this is exactly what we have seen where in the when I was drawing the diagram, a peer-to-peer diagram. Okay. Okay, now let's come to understanding blockchain structure that we have already covered. Node, here you will see the definitions that I have written. So node is any computer that connects to the blockchain network. Like I said, it's just a user, it's just a computer. Each node stores a copy of the blockchain. If you guys remember, when I was telling you about using the diagram, sorry, when I was taking the example, Alice, Bob, Charlie, David, Eve, okay? And if you remember that classroom example, so when a winner is, winner is selected, his or her copy will be distributed to everyone. Once the approval is done, the winner will get the photocopies and it will distribute to everyone. So everyone will store a copy of the notebook. Here we store a copy of the blockchain. Okay, and participates in the network processes such as validating transactions. For example, in the Bitcoin network, each user mining or each user running the Bitcoin software is the node or Bitcoin node. If you run Bitcoin software into your computer, you will become a Bitcoin node. Okay. Now block header. Block header, we have seen block header contains the metadata about the block and includes the following components: index, previous hash, nonce, and timestamp. And there's another which is current hash. Okay. So index, I told you, it's a unique identifier for each block in the blockchain. The first block with index 0 is known as the Genesis block. Previous hash, the hash value of the previous block. Nonce, I'll explain what this nonce is. Okay. Timestamp, that the exact time when the block was created, ensuring chronological order. A chronological order. Why it's not moving? Why my keys are not working? Okay, yeah, current hash, the unique hash of the current block. We know what block data is, just store the list of the transactions in a Merkle tree. Okay, Merkle tree is used to verify large amount of data quickly and efficiently because it stores hash. Okay. See, each leaf node in the tree represents a hash of a transaction. Okay, and each non-leaf node is a hash of its children nodes. Okay, so it becomes really easy for verification. Now this is the diagram. If I make it a bit close. Okay, so this is how blocks are connected that I have shown, and they are dependent on time. Okay, they are dependent on time, that after every 10 minutes a block is created in Bitcoin. Okay. Why my keys are not working? Okay. Now, as I discussed, what are addresses? It's like we have bank account, we have UPI ID, which shows the destination of the fund where we are sending to. That's exactly inside the blockchain or cryptocurrency. So an address is similar to a bank account or an UPI ID, where we can send and receive cryptos. Okay. In our blockchain, it is a unique identifier that represents a possible destination for cryptocurrency payment. Okay. It represents a possible destination for a cryptocurrency payment. So this is how our address looks like. This is how our address looks like. Okay. It is now Again, what I told you, it is derived from user's public key through a series of cryptographic process. Okay, now you can create your own addresses as well. Okay, you can create your own Bitcoin address. For that, you guys have to follow something, some procedures. Devdatta is asking, sir, then how torrent? No, it's not different. See, torrent uses peer-to-peer network. Okay, if they are same, can we use torrent in blockchain? Uh, See, if you want to do illegal work, then you can use blockchain. Okay, for selling these free movies, or let's say any media. Okay, all right. Now I'll come back to here again. You guys can create your own address as well, public address, and your own private key as well. Thus, it's very easy. It's very easy. You just have to follow some procedures, and you are able to create your own Bitcoin address. Okay, and if you don't want to create, there's a website I'll share with you, bitaddress.com. Yeah, bitaddress.org. If you guys can see my screen. Okay, so the points that you can see on my screen right now, the green gate, it's generating a random number, because that random number generates your public and private key. It uses an encryption algorithm known as elliptic curve cryptography. So if I just move it here and there till it reaches to 100%. Now, if you guys can see on my screen, there are two QR code. First is share and other is secret. That means this is Bitcoin address. This is your public key, which means share, public key, and this is your private key. I was not supposed to show you, but it's just for example. I don't have any asset. Okay, so you can create. If I just refresh this website, it will be lost. Okay, they will create a new address and a private key for me then. Okay, so this is how you can create your own Bitcoin address. All right, this is a website I'll share with you. Madhav is asking, why do we store only the previous hash in the block head and not the whole block data? Yes, again, that's to save the space. Okay, that's why we are using hashing, right? Because hashing gives the output, the fixed output. Okay, which is of smaller length as we compare to the actual data. The actual data is really large, 2,907 transactions. Okay, so it's really we have to save the space, right? So now you guys can go to this website bitaddress.org and create your own public and private key. Just visit this website. I'm giving you 2 minutes. Try this. Okay. And the thing is, you can take a screenshot of it. Once you take a screenshot and took a physical printout of it, it becomes your uh, the most secure wallet, because it's in your hand. Okay, it's in your hand, not on the internet. Okay, because here it's only for once. If I refresh the website, it will remove it. Okay, it will now create a new for me. Okay, so you guys can visit this website. I'm giving you 2 minutes. Okay, try to create your own public and private key. Behind this application, they are using elliptic curve cryptography. Okay, mathematics to create your own private and public key, and then showing you in a UI manner. You can see the QR code. Okay, now if you can see my screen, guys, if I go to paper wallet, so this is the paper wallet which Europe and America are using. Okay, you will see the actual ATMs for Bitcoin, where they have printed this kind of papers only. Okay, I mean, not the private key one, this spend one, but this Bitcoin address, the public key. Okay, you can just take a printout of it. It creates a Bitcoin address. Okay, you have single wallet, paper wallet, bulk wallet. Okay, here you can have three things. This is address. First thing is address, and this is the private key. This is the second address, and this is the private key. Third address, and it's private key. Brain wallet. What is brain wallet? Interface. Okay, here we have to create with our own vanity address. We have and their part private key. Split address wallet. Split means, suppose if you want to, I'll discuss all this. What split wallet is it? Wallet details you can see here. Okay. It's a open source JavaScript client side Bitcoin wallet generator. Have you tried? Have you tried creating your own? Just let me know. Just let me know. And Madhav, to your question, hashing is also done for verification, right? So if you do store only the data, how will you verify if the data has been tampered or not? That's why you use hashing, right? Have you tried, guys, using to create your own public and a private key using this website? Just let me know. Okay. Only one is replying. You can just do this. I'll understand. I think you guys have this option, right? The reactions one. Cool. Okay, so now we have seen we can create our own Bitcoin address. Okay, now you can use it. You can, suppose if you got one Bitcoin, suppose you want to receive one Bitcoin from someone, so you can give your a public key, not private key, to that person, and they can send you. Okay. Now if I come to my book again, okay, so this is how we create. So I have written a public key generated from the user's private key. It is used to create the public address. The public key allows others to send cryptocurrencies to the user. Now what is private key? So this is the sample key. See, this is how public key look like. So we have to create a hash value of it so that it becomes small. Private key, a secret key known only to the user, which is used to sign transactions and access the funds associated with the public address. Okay, keeping the private keys secure is crucial, as anyone with access to it can control the associated funds. If anybody is holding your private key, okay, they can control the associated funds with that. Okay, this is how a private key looks like. Now I was saying from the first day, and I will say, okay, till we have completed with this 15-day program. Always remember to not share your private key with anyone, as allowing anyone to possess your private key directly means giving your crypto ownership to others. So that's why there's a saying in the crypto world: not your keys, not your coins. Not your keys, not your coins. If you don't hold your coin, sorry, if you don't hold your private key with yourself, and if it's with someone else, they can do the transaction. What happened with WazirX? WazirX is a centralized platform. It's a centralized exchange where you can trade Bitcoin or any other cryptocurrency. They hold your private key with themselves. So that's not what Web3 is. It's again a Web2 only, but they are using it for trading purposes. CoinDCX, WazirX, they all are susceptible to the vulnerability. If there's a loophole in the security, anyone can, you know, anyone can, what do I say? Yeah, they can hack the database there, and can gain the private keys. Okay, so if a hacker got your private key, they can do whatever they want to do with your funds. Okay, so that's why right now, if you guys into crypto trading, coin DCX or let's say WazirX, we have seen the biggest crime that happened, the biggest hack. Okay, that happened with WazirX. It happened to coin DCX also last month. Okay, but the thing is, centralized exchanges are really easy to use, guys. So that's why people rely on it. Okay, people use them because it's much easy, because you can directly buy your cryptocurrency using your fiat money, the Indian rupee. But if you see decentralized applications like Uniswap, we have Uniswap. Okay, I'll show you their website. So Uniswap is a decentralized market. Like CoinDCX, WazirX are the centralized market. Uniswap is a decentralized market. Okay, it totally works on blockchain. So they don't hold your private key with themselves. I'll say it again. They don't hold your private key with themselves. So if you can see my screen, guys. So this is Uniswap. So suppose I can select token. There are multiple tokens you can select. Suppose if I'm selling Ether, and then if I want to exchange it to another token, I can select the token. Suppose Tether. Okay, right now I don't have any coin. Okay, but here the thing is, you don't have to, I mean, sorry, your private key is not stored somewhere. Okay, it's not stored somewhere. All right. So this is a decentralized market. But again, it's really difficult. You must be having Ether first. Then how will you buy Ether? Okay, so it's something challenging in decentralized space. So that's why people are using centralized places like CoinDCX. People use CoinDCX a lot. Even I am using CoinDCX. Okay. Now let's come to wallets. Okay, let's take a 10-minute break. Okay, you guys can have water, and then we'll meet after 10 minutes. Okay. Then we'll study what these wallets are. Okay, very interesting. I'll share you a story. Yes, Abhay, the WazirX scam. Delta exchange use. What do you mean by it? Okay, we'll discuss. Okay, let's take a 10-minute break. We'll meet at 8:25. Okay. Okay, let's start. Just give me a heads up if everybody is ready. Cool. Okay, so now let's understand what a wallet is. Okay, what a wallet is. What a wallet do? Every wallet, I mean the physical wallet that we carry. What do a wallet do? What it carries? It stores money, right? It stores the physical cash. Okay, and suppose if someone asks how much you are holding right now, so what we do, we give the aggregated amount, right? Suppose I have a 500 rupee note and a 200 rupee note, so I'll say I have 700 rupees, right? This is what we say, right? But when we talk about this wallet in the cryptocurrency, when we talk about this the wallet concept in cryptocurrency, okay, it's something else. Why something else? Because as I told you, coin is nothing. Coin is nothing, just an entry. So with just an entry, what this wallet is storing? What this wallet is storing? If coin is nothing, it's just a virtual representation. Okay. So what does a wallet hold inside the world of cryptocurrency and blockchain? So the answer is a wallet stores your public key and a private key. Because this is what a coin is, right? This is what a coin is. Your private key is your coin. Okay. So a wallet in cryptocurrency or blockchain holds your public key and a private key. Okay, because coin is nothing. So that's what I have written in my book. Now, there are various kinds of wallet. There are various types of wallet. See, this diary, if you see, I told you this diary is holding 16,000 worth of Solana. I have written my private key here. So this diary becomes my wallet. This diary becomes my crypto wallet. And I call it as a paper wallet. Paper wallet. It's in a physical form. The safest way to be safe in crypto world is just write your private key on a piece of paper. The safest way. The safest way. Okay. And never, never, never lose your copy or lose your paper. Okay. So this becomes your paper wallet. This becomes your paper wallet. Okay. Now we have online method as well, and they are known as software wallets. They are known as software wallets. But all these kinds of wallet are categorized into two wallets: hot wallet and a cold wallet. Hot wallet, cold wallet. Hot means connected to internet. Cold means not connected to internet. So paper wallet. Paper wallet comes under cold wallet. Okay, it comes under cold wallet. Okay, now let's read it. Everybody knows what MetaMask is? What MetaMask is? Everybody knows? If no, we'll discuss. Okay, wallet. A wallet in the context of blockchain is a digital tool that allows users to store, send, and receive cryptocurrencies and also monitor the balance. I told you in the physical we have, suppose I have a 500 rupee note and a 200 rupee note. So if someone asks how much you are holding, so I'll say 700 rupees. Okay. So it monitors the balance as well. Now, very important thing which I have underlined. It doesn't actually store cryptocurrencies like physical wallet stores cash. Okay. It doesn't actually store cryptocurrencies like a physical wallet stores cash. Instead, it stores the cryptographic keys required to access and manage these digital assets. It stores the cryptographic keys required to access and manage these digital assets. Okay, now there are of many forms: paper wallet, hardware wallet, software wallet, and an exchange wallet. When you categorize these four into two again, I mean into two more, so they are known as as cold wallet and a hot wallet. If you guys can see on my screen, hot wallet and a cold wallet. Hot wallet, again, they are connected to the internet and stores crypto online. They are not safe. Why they are not safe? Because as they are connected to internet. Okay, suppose if somebody intrude into your computer, they can easily see it. They come under software or exchange wallets. Okay. Now, what is a cold wallet? Simple. That stores your cryptos offline without the need of internet. They are much secured than the hot wallet. They come under paper or hardware wallet. So hot wallet contains software and exchange. Cold wallet contains paper wallet and the hardware wallet. Okay. Okay. Now let's see. Now let's understand what paper wallet is that we have already seen in the website bitaddress.org. This is what we have seen. If you remember, if I show you here, see, this is paper wallet. This is the screenshot I have taken from here. It's a paper wallet. Just take a screenshot of it. Just you can see a print option here. Just print it out. Okay, it becomes your paper wallet. Physical printouts of the public and private keys. Yeah. Often in the form of QR codes. The most secured is just by writing down the public and private keys on a piece of paper. Okay, that's the securest way. Okay, now we got hardware wallet. They are little pricey. Okay, there are some companies like Ledger and Trezor. They are offering. So if you can see it here, these are physical devices. Okay, to securely store your private keys offline. Okay, they are little pricey. And one of my mentor, he was holding Bitcoin in the year 2011 or 12. So he hold those private key inside this ledger. I mean this hardware wallet, but he lost it. So he lost crores of Bitcoin. Not yeah, crores of rupee worth of Bitcoin. Okay, they are little pricey. If you guys want to see them, you can just Google Trezor Ledger. Okay, let me just show you. Ledger hardware wallet. Okay, so this is how we can see here. Now they have much better way. See, you can see it. Ledger Flex, Ledger Stacks, Ledger Nano Range. Oh wow, physically secure transactions with Ledger crypto wallets. Thousands of supported coins and tokens. Ledger Live, the crypto companion app for your Ledger crypto wallet. You can see it now. Okay, so all these comes under hardware wallet and a cold wallet. Away from the internet. Away from the internet. All right. Now coming back here. Now we get software wallet. Software wallet. Now for this, I want you guys to install MetaMask into your computer. It's very easy. I'll show you. So what you have to do, just if you're using Google Chrome, just go to Google extensions. You can download it from there. I'll share my direct screen instead. Wait. No, but it's not a cryptocurrency. MetaMask is a wallet. Okay, it's not a cryptocurrency. It's a wallet. Wait, I'll share my entire screen instead. Okay. So if you search for MetaMask, okay, you can do it from here. It's already downloaded. I can show you here. You can, if you guys know what extensions are, so this is my extension of MetaMask. Okay, see, it's my extension. I haven't logged in right now. So if you log in it, okay, I wanted to do it right now. I want you guys to just download it. Okay, see, it's available. Okay, so I wanted to guys download it. Okay, Just download it and let me know. Yeah, important thing, once you try to log in, they will give you a mnemonic seed or a seed phrase that are independent. They are very anonymous words that are given to you. For example, I have written it here: rabbit, London, vegetable, cartoon, sofa, music, plastic, quote, achievement told. So they are randomly generated words, and they are your private key. They are your private key, guys. Okay, so never share it to anyone. And they always say, when you try to install this now, so they will say, write it on a piece of paper or where it's really secure. Okay, don't try to store it online. This is also what they say. Okay, try to create your ID on MetaMask. Okay, try to create it. So they will give you this mnemonic seed or seed phrase. Always, also remember, if you lost this seed phrase, just forget, on how you can access your MetaMask again. Okay, it's not possible. So if you lost your seed phrase, you will lose your cryptos as well. Okay, so it's for one time. That's one of the worst thing in Bitcoin. Sorry, in blockchain. If you lose your private key, you will not be able to access your things again, your assets again. It's not like you can do forgot your password. That's not possible here. Okay, it's not possible. You cannot do forget a password here. Okay, so always save them in a place where they are really safe. Okay, try to create it or do it after the class. Okay, so you will get this mnemonic seed phrase. They are calculated from private key only. Because private key, if I guys show you again, so private key, this is how it looks, right? See, they are really complicated to understand. If a single letter is changed, okay, it's complicated. Suppose in an address, this is the address. I showed you address. 1 AAE 1DE. Suppose this is the address. So that belongs to Manteve. Now suppose a person wants to send me crypto. So what I'll do, I'll send my address to that guy. Now if that person by mistakenly change a bit data, suppose from instead of F he wrote E. So the crypto will be sent to someone else. If it is with a if it is with a someone or not, it doesn't matter, but it will not be received by me. Okay, so it's really hard sometime. Okay, so you have to make sure you are writing everything right. Okay, not a single mistake has to be done here. Now coming back here, so yeah, this is what software wallets are: MetaMask, Trust Wallet. All comes under software wallet, and they are hot wallet connected to internet. Now comes exchange wallet. Like I told you, CoinDCX, okay, or WazirX. They all are centralized exchanges. Exchange means where you can exchange your crypto with one another. So they are known as crypto exchanges. And every crypto exchange has their own wallet. So if you are using CoinDCX, they have their own wallet. Okay, WazirX, they has their own wallet. Now the biggest problem is, which I have discussed earlier also, that they are centralized system, which means they hold your private key with themselves. Okay, so that is also known as, I mean, these exchange wallets are known as non-custodial wallets. Non-custodial wallets. I'll write it here. Where's my pen? Very important thing it is. Yeah. So when we talk about these centralized exchanges, okay, their wallet, their wallet is also known as custodial wallet. Why custodial wallet? Why custodial wallet? Because they have custody of your private key. They have the custody of your private key with them. Okay, that's something which is really not safe. If there's a hack, might be you will be getting lose. Okay, you will lose your private key. Okay, so that's why they're known as custodial. Custody. Your private key is in the custody with themselves, with their centralized platform. Okay. Now we have another which is known as, I'll write example as well. Example, let's say coin DCX or WazirX. Okay, even Binance. Okay. Then we have decentralized exchanges that totally works on blockchain. Decentralized exchanges. Example we have, I told you, Uniswap is the example. We have Sushi Swap as well. So there are various, okay, etc. Now their wallet is known as non-custodial wallet. They are known as non-custodial wallet because they don't they don't control, or they don't have, yeah, they don't have possession. We have two S, right? Possession. Oops. They don't have possession of your private key. Cool. So decentralized exchange and a centralized exchange. Centralized exchange are also, their wallet are also known as custodial wallet, and decentralized exchanges wallet are known as non-custodial wallet. Okay. Again, I'll go to book. These are all the types of software wallets, but are provided by exchange platforms. For example, exchange wallet provided by CoinDCX, Coinbase. Now, everything which I have written in this cloud, I mean every cloud which you will find inside this block, inside this box, okay, it's a note kind of thing. Okay, so I've written it here. If there is a centralized exchange, then they have the custody of your cryptos, which is not good, as if they go bankrupt, all your cryptos will be gone. Suppose, touch wood, if suppose one of these centralized exchange, let's say WazirX, if they go bankrupt, okay, you will lose your cryptos, you will lose, okay, because they have possession of your private key. All right, so these are what wallets are. So I want you to create your own wallet. Okay, best is try with MetaMask, or you can try with Trust Wallet as well. Okay, uh what extension link? Abe, yes, you can do SIP in Bitcoin. Yeah, you can use these centralized exchanges. They have provided with this option. Okay. Madhav is saying custody wallet, since the exchange holds a private key, don't that make it similar? Exactly. Yes, Madhav. So we still they are trading cryptos, which is a part of Web3. But the method they are using, it doesn't come under Web3. It's the old method, centralized platform. Similarly to the bank holding our funds. Yes, exactly. Okay. But the thing is, in banks you can access it. But yeah, here also you can access it until unless they didn't go into bankruptcy. Okay. Any other doubts? But yes, you can do SIP in Bitcoin. Any other doubt, guys? Just let me know. I think it's easy to understand what wallet address are. Okay. So I want you to try with MetaMask. You can try it with MetaMask. You can try Trust Wallet. Okay. There are various. Okay. Now I'm finding a way on how you guys can transfer free bitcoins and let's say dummy coins to each other. Because right now when I started blockchain in 2019, that was at that time it was really easy, but right now it's so congested. The network are so congested, so it's really difficult to get those dummy coins for your practice. Okay, because we are more than 200 people, right? So it becomes really difficult. So we all try to do it. So it's really impossible to do. But I'm trying. I'm trying to find a way. Any doubt, guys? Just let me know. No doubts? Where is Nilesh today? Nilesh is not there. Okay, there's a question. Oops, wait. Oh wow, that's really great. So where did you get that? What faucet did you use? Alchemy or Tenderly? I guess you must have used Alchemy for that. And Devdata, you must have seen that they say, please return these crypto back to them, right? Because there are various people who are using it. Okay. So have you tried to exchange to someone, let's say to your address only to another address? Have you tried doing that? Okay, Google Cloud Web3. Okay, okay, that's great. Even I'll also see what this thing is. I'll tell. See, Mohammed, we see right now, Bitcoin are really expensive. Ethereum are really expensive. So how can we use it for our practice? So there are some dummy coin. There are some free coins. Okay, that doesn't have any value, but they are just for practice. So these test that means it's not the actual thing. It's just for a practice. For just testing. So it's a testing environment where you can get these free tokens. Okay, that doesn't have any real value behind it. Just free tokens. For instance, I'll show you. I have something which is known as Ganache. I'll show you there it's working when I'll tell you the how we'll create smart contract. Okay. Yes, yeah, I have made a fund means smart contract exactly. I'll show you if my screen is visible. So this is a Ganache which provides you with some free tokens. Okay, but it's limited. Okay, you cannot send it to someone else. So if I create a new, oh sorry. If I click on the quick start Ethereum, okay, you can see I have 10 addresses here and every address has 100 ether. They are dummy coins because one ether is more than 3 lakh rupees. That means how much it would be? 30 crore. Okay, so these are for your practice. You can see blocks created. Okay, when we'll create a smart contract, right? So everything will be recorded here. We'll see the transactions, we can see the contracts, events, logs. Okay, so when we will be proceeding to creating smart contract, then we'll use it. Okay, because running a smart contract needs fees. It's like when you go for driving, you need fuel, right, for your car. Similarly, if you want to run a smart contract, you need fees, you need some fuel, and this fuel is in the form of cryptocurrency only. Okay, I guess no doubt. So now if we are talking about Ethereum, so I want to tell you guys about Ethereum. Okay, so if you guys remember what I told you about Bitcoin initial purpose was to be a single currency. Okay, only just a currency for transaction, right? But when Ethereum came, Ethereum said that we are not here as a currency. We are here to provide users to create their own decentralized applications. Decentralized applications. Okay, to create your own decentralized application, which is something really important. And how these decentralized applications are created? They are created using smart contracts. Okay, now what is a smart contract? In a very easy explanation, I'll tell you. Suppose we all have went for cash withdrawal, okay, to ATM. We all have gone, okay. Now, how do we withdraw money from ATM? There are some steps, right, that you have to follow, that have to be fulfilled before. So what is the first step? First step is enter your card. Second step is enter your PIN. Third step is withdraw, or let's say withdraw, no, choose saving or current. So let's say you chose saving. Then they ask you withdraw or deposit. You will click withdraw. That's the fifth step. Sixth step, how much money you want to withdraw. Seventh step, again you have to provide the PIN. So when all these 7 steps are fulfilled, once all these are met, then ATM machine will dispense out the money for you, right? It will dispense out the money for you. You will get the money. Now tell me guys, do we require help of any intermediary or a bank to facilitate this transaction, or everything is encoded inside the ATM machine? What do you think, guys? Exactly, Amna. Transaction which are executed automatically by a computer program or a transaction protocol. Exactly. So it's a normal code only. So ATM machine, we don't require help of anyone, right? To withdraw the money. Everything is encoded inside the machine. Okay. So that we can say it's a smart contract. Okay. But we call it as a smart contract only when it is connected to a decentralized network. Right now, ATM is connected to bank. So bank can see your information that month I withdraw, let's say 1,000 rupees. So we can say it's a normal code. But if it's a decentralized network, we'll call it as a smart contract. But just a fancy name for a normal code on a decentralized network. Okay. Cool. So I think we have no doubts now. Okay. Yeah, I guess we have now Saturday and Sunday. We'll be meeting on Monday. So on Monday, we'll see one more important concept, which is known as consensus mechanisms. What is a consensus mechanism? Someone said me proof of work. So proof of work is just a mathematical puzzle that we have seen. So to run a decentralized network, there should be some mechanism. There should be some rules. They are known as consensus mechanisms. Okay. So that mathematical puzzle is to create, to run a blockchain network, which are really efficient as compared to this mathematical puzzle. Why? Why? Because if you see in a mathematical puzzle, when we were seeing the running of Bitcoin, so these mathematical puzzles require lot of computations. Your computer has to do a lot of computations per second. So where your computer is getting energy from electricity, and where the electricity is coming from, it's coming from coal. So it's not good for environment. Okay, just to create a block, okay, you are using a lot of energy for it. Okay, so there are various other ways which are really efficient as compared to proof of work, which is used by Bitcoin. So we'll see those mechanisms as well. All right. Madhav is saying, if I use a hardware wallet, is it true that my private key never touches the internet? Yes, yes. So even a phishing attack can't directly steal. Exactly. So as long as I know hardware, like also hackable, like in real entity, we can be destroyed. Yeah, if you destroy your hardware, it's not retrievable then. Okay. But I always say that if you are using a hardware wallet also, now try to do it when you are not connected with internet. Okay, because criminals are really smart, they can do anything. Okay. All right. So always use when you are not connected with internet. Just disconnect your internet for a while, transfer your private key, and then you can get back online. Okay. So this is what you can do. Any other doubt, guys? Yes, we will be making. Okay, Madhav. So what happened in Binance case in 2019? Can you just tell me in short? See, Binance is a centralized system, like I told you. Yeah, again, because it's a centralized system, social engineering tactics, right? So you can they were able to retrieve the private keys of the users. Okay. Any other doubt, guys? All right, I guess. MetaMask, see, again, it's a hot wallet. Okay, so it's again susceptible to the crimes. Okay, the cyber crimes. All right, and suppose if you stored your seed phrase in an online manner, sorry, on somewhere online, so it's again vulnerable. Okay, but MetaMask is providing a security that they are really safe. Okay, but they are really safe until unless someone finds a vulnerability inside their system. Okay, so this advantage is that it's really easy to use. Okay, it's really easy to use as compared to physical, sorry, the paper wallets and everything. Okay, disadvantage, the only disadvantage is that they are hot wallet. They are connected to internet. Okay, thank you, Devdutta. Okay, then everyone, let's meet on Monday. Okay, have a nice weekend.